Today is to continue on instance centers, and we did an example of a 4-bar. And now, is this the limit?
Yes.
So now what I want to do is go ahead and do a couple more examples here. So now, let's go ahead, say another find all the ICs for instance centers on a mechanism example problem. So now we're going to do a crank slide. Let me go ahead and set up the crank slide. Say it looks like that right there, right? Let me go ahead and label all of the links. So here's link 1, 2, 3, and 4. Okay? I'll set up my circle diagram. And the circle diagram, as I was saying the other day, has no geometric meaning. It's just a matter, it's used to for bookkeeping purposes to track and identify missing centers. So all the tick marks on the outside are representing link numbers. So we have ground, input, and the coupler in the sliding block. That's what those numbers are representing over there. So we got ground, the input, the coupler, and sliding block right there. What I'd like to do is find all the obvious instance centers first. So the easy ones I'll do in green here. So there's an instance center between 1 and 2 right here. So that's I12. Here's I23. I34. And one that may not be so obvious, but we talked about before, for something that is experiencing pure translation. This block here is experiencing pure translation, sliding on this ground. So that instance center there, I'll just put an arrow that I14 is at infinity. So let me stop there. Is there any questions on how I got those 4 instance centers? All right, so once we have those for bookkeeping purposes, let's go ahead and mark these off here. So this represents I12. This represents I23. I34. I1. All right. And so the trick is here, using this circle diagram, is you look at the circle diagram and you look for a quadrilateral. So in this case here, I see a quadrilateral right here. And in the quadrilateral, what you do is you bisect it. It has, this quadrilateral has two diagonals. It has a diagonal here, and it has a diagonal here. And that will help you identify the missing instant centers. So let's go after this one right here. Let's go after, let's say, I13. So I'll draw a dashed line representing that I'm currently going after I13. And so if you look at this, Kennedy's theorem says that 3 instant centers lie all on the same line. So instant center 1, 2, and 2, 3, and 1, 3 lie on the same line. So let me draw a line through 1, 2, and 2, 3. So when I draw that line right there, I know that I13 lies on this line because of Kennedy's theorem. So then let me go on the opposite side of the diagonal. If I draw a line through 1, 4 and 3, 4, 1, 3 lies on that line too. So let me go ahead and 1, 4 is off at infinity. Here is 3, 4. So let me extend this so you can clearly see what's going on. So I know that I13 lies on this line too. Therefore, where the two intersect, this right here is I13. Once we find it, let's go ahead and take our dash line on the circle diagram and make it solid. Okay? So we're not done with this quadrilateral. So again, the quadrilateral is 1, 2, 3, 4, back to 1. So let's go ahead and find this diagonal, which represents I24. So let me go ahead and make a note to myself that I'm looking for I24, so I'll draw that as a dash line. And if I draw a line connecting 1, 2, and 1, 4, I know that 2, 4 will lie on that line. So how this works is here's 1, 2. 1, 4 is at infinity, but remember I said that these parallel lines intersect at infinity, so what I'm going to do is I'm going to keep on drawing a parallel line here until I get a parallel line that goes through 1, 2. That means that I'll have, so when I do that, so if I move this thing over, and I draw this right here, I know that I14 is at infinity down this way because it has to be parallel to this line right here. Because I know that 1,4 is at infinity, so I just keep on drawing parallel lines until I get one that goes through 1, 2, because that's what I'm trying to do with this right here. I'm trying to go through 1, 2, and 1, 4. So the other line that I draw is the line through 2, 3, and 3, 4. So when I do that, 2, 3, and 3, 4, I get this right here. So on both these lines here, I24 lies on these lines. Therefore, where they intersect becomes I24. And I can make that solid. Yes?
So the I14 at infinity, it doesn't matter where at infinity? Because you said it has to be a vertical line.
Yeah, so I14 is way off there at infinity or way down here at infinity.
But doesn't it have to be, it just has to be somewhere between 1 and 4? It doesn't have to be below 4? Because you have it drawn,
Yeah, so right here, because I know that the direction of travel is this thing here has to be perpendicular, this line has to be perpendicular to the line of travel.
but it doesn't matter.
But I could have, if I wanted to, I could have drawn it so that I say I-14 at infinity. I could have drawn it like that.
So it doesn't matter where horizontally it is?
Mm-mm. Or I could have drawn it like this. As long as all these lines are perpendicular to the direction of travel. Okay? Other questions on this? We're going to do a more complicated one next. All right. So let's go ahead.